Okay, this is our third page of our review. For number 9, we're given 3 polynomials and asked to factor them as much as possible and then find the zeros of each. So factoring largely is going to rely on our classic method of factoring trinomials. However you're most comfortable doing that, I would encourage you to do it definitely the way I showed you, because that's something you should be an expert on. So remember, I start off factoring always by looking for a greatest common factor. So like in A, I would factor out a 2x squared. After I factor that out, I will be left with 3x squared minus 2x minus 8. I'm not going to show all the factoring here, that's left to you. But here I would need factors of negative 24x squared that adds negative 2x. That would be negative 6x and positive 4x. To make a long story short, how does this factor? Well, I will have 2x squared times 3x plus 4 x minus 2. And you can check that that does work. You can factor it yourself. You're also asked to find the zeros of each. So this is my complete factorization. For my zeros, well, I have the factorization right there. So my zeros would be, I can see I have 0. Its multiplicity is 2, in fact. 3x plus 4 would give me a 0 of negative 4/3. Think about setting it equal to 0. You can write it out even. Subtract the 4, divide by 3, I will get negative 4/3. X minus 2 will give me the 0 of 2. Let's take a look at B. Again, we want to look to factor this. The greatest common factor of all 4 terms there is 1, so I move right into how to factor a polynomial with 4 terms, which is to group. So I'll group the first 2 terms and the last 2 terms. Take out x squared times x plus 3. Down here take out negative 9, be left with x plus 3. So this factors by grouping, and I'm left with x squared minus 9 times x plus 3. Well, x squared minus 9 is a difference of squares. It factors as x plus 3 times x minus 3. And I already have this other x plus 3 here. So the factored version of g of x is actually x plus 3 squared, x minus 3. What are my zeros? Well, my zeros are negative 3, which has a multiplicity of 2, and positive 3. We see a lot of these ideas come together as we finished our unit on polynomials. We have, I just brought up multiplicity. We've talked about solving by factoring before. I have here a degree 3 polynomial, which means it has a total of 3 roots. What are my 3 roots? 3 and negative 3 with a multiplicity of 2. That is a total of 3 roots. Now let's take a look at C right here, which is the trickiest of these. Here I want to factor x to the 4th minus 4x squared minus 45. It's tricky, but there's no trick. It's just a matter of remembering what our process is. Here I will write out the work. I will need factors of negative 45x to the 4th adding to negative 4x squared. Well, if it has to add to something with an x squared, I will need 2x squared terms. What multiplies to negative 45 and adds to negative 4? Well, of course, that is plus 5 and minus 9. I can go through the rest of my factoring right here. I can group the first 2. That's x squared times x squared plus 5. Minus 9 times x squared plus 5. So finally, what am I getting here? I have that this is equal to x squared minus 9 times x squared plus 5. Well, x squared minus 9, we factored that just a moment ago. That's another difference of squares. So my factorization would be x plus 3, x minus 3. Now x squared plus 5, not only is that not a difference of squares because it's not subtraction, 5 is not a perfect square. So I have my factorization. That was what I was first asked for. I also want my zeros. So remember what I would do. I would take each of these factors and set them to 0 and solve. X plus 3 would give me negative 3. X minus 3 equals 0 would give me positive 3. I can write the two of those together as plus or minus 3. And how about x squared plus 5? Well, let's actually write out that work. Apologies here, it's getting a little bit messy. If x squared plus 5 equals 0, I am primed to solve by square roots. Isolate the x squared, and then I will take a square root. Whenever I take a square root, whenever you take a square root, you need plus or minus. The square root of negative 5, as soon as I have the square root of a negative, I know that means to pull out an I. So I now have my zeros, plus and minus 3 and plus and minus I square root 5. Again, going back to the fundamental theorem of algebra, this is a quartic. I expect 4 roots, and I find 4 distinct roots. 3, negative 3, I square root 5, and negative I square root 5. Next solving problem that is here, I'm asked to solve the equation 6x cubed minus 29x squared equals 5x. If I subtract to get 0 on one side, as I must, I have this. My common factor is x, and I'll begin my factoring, which means I don't need the 0 while I'm actually doing the factoring. And you can do some work to factor this. You'll need factors of negative 30, which add to negative 29. That's negative 30 and positive 1. I'll leave the factoring to you, but what I should have here is x times, if I need negative 30 and 1, that would be 6x minus 5x 1. 6x plus 1, x minus 5 are my factors. Little glimpse into how I learned how to factor right there. Alright, so now I need to solve this. So of course my next step is to take each factor and set it to 0. X equals 0, well, x equals 0. X minus 5 equals 0, obviously x equals 5. And here, be careful, 6x equals negative 1, divide by 6. So my solutions are x equals 0, negative 1/6, and 5. Okay. The next topic we had was polynomial theorems and writing equations of polynomials. Now, writing equations of polynomials can get very challenging. We didn't really dive that deep into it. It's not something to really worry about. We'll worry about writing factored forms, and I'll briefly explain the process of how you would turn the factored form into the standard form. But really, it's not something to stress yourself about. So the first question tells us a polynomial with rational coefficients has a certain set of roots. Well, our theorems told us that if I know, our theorems were actually the fundamental theorem of algebra, which we made reference to. If I know a polynomial has a certain degree, it has that many roots in total. The factor theorem, which is if I know a polynomial has a certain root, then it has a certain factor to go with it. And finally, the conjugate root theorem, which the conjugate root theorem tells us that for our purposes, funky roots, that is, anything that has a square root that doesn't simplify all the way, or something with an I, whether it has a square root or whether it's just something like 7i, all of those come with a partner, namely the conjugate. So here's some examples. 5 minus 2i, if that is a root of a certain polynomial, then 5 plus 2i must also be a root. Notice I've changed the operation in between. If negative 3 plus the square root of 7 is the square root of some polynomial with rational coefficients, which for us that's everything, then negative 3 minus the square root of 7 is also a root. That's the conjugate expression. Notice I'm changing the sign or operation before the imaginary or square root part. If 2i square root 5 is a root of some polynomial, then so must negative 2i square root 5, that must also be a root. And again, if negative 3 square root 15 is a root, then so must 3 square root 15 be a root. So what do I have here? A polynomial with rational coefficients. Again, that's for us everything, so we can always assume this for the problems we're going to work with. Has the roots negative 3 square root of 10 and negative 1 plus 7i. We're asked two questions. What other roots must this polynomial have, and what is its minimum degree? Well, the conjugate root theorem tells me that the square root of 10 and negative 1 plus 7i, each of those comes with a partner. So the other roots that I must have, if I have the square root of 10, it follows that I must also have the negative square root of 10. And if I have negative 1 plus 7i, what must follow? Negative 1 minus 7i must also be a root. So then, the question is, what is the minimum degree of this polynomial? Well, I now know that I have 1, 2, 3, 4, 5 roots. 5 roots would imply that the minimum degree is in fact 5. And it is that simple. These funky roots, anything, not fractions mind you, fractions and integers can come by themselves. But anything with a funky square root that doesn't simplify, or something with an I, that's going to have a partner with it. I want to give the factored form of a polynomial with certain roots. This is the writing part. So here in A, I have the roots 2, 2, 0, and negative 3/5. Well, 2 is listed twice, which means that 2 must have a multiplicity of 2. Now it says the factored form of a polynomial. It doesn't say polynomial function. I'll go ahead and write it as a function. We'll say p of x. If 2 has a multiplicity of 2, I should see x minus 2 squared. 0 would come from the factor of x. And a bit tricky, but we did discuss this. If I have negative 3/5, negative 3/5 would actually come from the factor usually 5x plus 3. And if you want to think about why that's the case, you got to essentially, the best explanation is think about solving in reverse. So like x equals negative 3/5. Before you get here, that 5 is usually up here. And before you get here, you would have set 5x plus 3 equal to 0. So that's where 5x plus 3 comes from. How about b? I'm given the roots negative 6, 4, and 1. So again, I can say p, f, g, q, whatever, doesn't matter. Again, technically it just needs to be a polynomial, which means I don't even need the equation. To have a factor, to have a root of negative 6, I need a factor x plus 6. To have a root of negative 4, to have a root of 4, my factor is x minus 4. And finally, to have a root of 1, I need to add on here, apologies, I've run out of room, I need a factor of x minus 1 multiplied in there. Now, rather than actually worrying about finding the standard form, how might we find the standard form of a polynomial in 12a? Or 12b for that matter. What does the standard form mean? Well, standard form is something like y equals 2x to the 6th minus 5x to the 5th plus 10x to the 4th plus a whole bunch of other stuff. Possibly some terms aren't there for a variety of reasons. But what this means is everything has to be multiplied out. So in general, what I'm going to do is multiply it out. Now strategically, if you were going to multiply it out, you have a lot of options right there. If it were me, I would probably start by squaring x minus 2. And that would get us x squared minus 4x plus 4. I would take that and multiply that by 5x plus 3. And you can do that, since we have a trinomial and a binomial, I could use either a 2 by 3 box or split this up and distribute. If I do that, what will I get? Just to show off a little bit, I will get 5x cubed minus 17x squared, let's see, plus 8x plus 12. And if I made a mistake, sorry, oh well. And then my final step in converting this to standard form would be to distribute that x, which would give me the final answer of 5x to the fourth minus 17x cubed plus 8x squared plus 12x. So I want you to understand that process. We don't really need to worry about doing that ourselves. But to just put this to bed, to find the standard form of a polynomial means to multiply it out.